Let's dive right into one of the most profound and, well, one of the weirdest ideas in all of modern physics. This all comes from the mind of physicist Leonard Susskind, and it suggests that everything you see, everything you are, might not be what it seems at all. Which of this whole thing is our universe, a hologram. And look, I know how that sounds, but this is not science fiction. We're talking about a serious scientific proposal, one that was actually born from a massive crisis that threatened to break physics itself. See, here's the background. For the last 100 years or so, our entire understanding of the universe has been built on these two spectacular pillars. We've got two theories that are just unbelievably successful on their own, but the moment you try to put them together, well, they pretty much declare war on each other. So, in one corner, you've got Einstein's general relativity. It's just beautiful, right? So elegant. It's the theory of the very large. We're talking planets, stars, galaxies, and that smooth fabric of space-time. But then, in the other corner, you have quantum mechanics, and it's kind of wild. It's this messy, probabilistic theory of the very small, atoms, particles, that kind of thing. So one describes this smooth, continuous world, and the other describes a jittery, jumpy one. And yeah, they just do not agree. Now, for most of the universe, this isn't really a problem, right? The two theories kind of stick to their own turf and don't bother each other. But there is one place where they are forced into this direct, just violent collision, and that's inside a black hole. Think about it. A black hole is both incredibly massive, that's relativity's home turf, and at its center, it's unimaginably tiny, which is quantum mechanics domain. It's the ultimate battleground. And this exact battleground set the stage for what became one of the greatest intellectual debates of the 20th century. People literally called it the Black Hole War. It pitted two absolute titans of physics against each other, fighting over the fate of reality itself. Stephen Hawking versus Leonard Susskind. The whole war, this huge debate, it all boiled down to one question that sounds simple, but is anything but. What happens to the information that falls into a black hole? So, let's say you throw a book in there. What happens to all the data that makes it a book? You know, the specific arrangement of atoms, the words on the page? See, quantum mechanics has a hard rule. Information can never be destroyed. But according to Stephen Hawking, it was just gone. So this was the absolute heart of the disagreement. Hawking's position was that the insane gravity of a black hole just permanently erases any information that crosses its boundary, the event horizon. Poof, gone. Susskind, on the other hand, was apparently horrified by this idea. For him, a fundamental law of the universe that information is always conserved had to be true. No exceptions, no matter what. And yeah, Hawking's position was pretty bleak. He argued that black holes eventually evaporate over billions and billions of years, right? They leak this energy, this radiation. But he said that radiation is completely random. So the information about what fell in, I mean, whether it was a star or your entire library, is lost forever. It's just scrambled into meaningless heat. For Susskind, though, this was just unacceptable. It would mean the universe is fundamentally unpredictable. I mean, think about it. If you can lose information, you lose the ability to trace back the past or predict the future. It breaks everything. He was convinced the information couldn't just be gone. It had to be somewhere. The big question was, where? And in that search for an answer, Susskind and a few others stumbled upon a solution that was so radical, so out there, it sounded like it came from science fiction. It was an idea that didn't just save the information, it totally redefined our concept of reality itself. They proposed that the world is a hologram. Okay, what on earth does that actually mean? Well, the holographic principle basically suggests that everything we experience in our familiar 3 dimensions, plus time, is really just an elaborate projection. The real, fundamental information that describes our entire universe, it's all encoded on a giant, flat, 2-dimensional surface, kind of like a screen at the very edge of the cosmos. The best way to think about it is like a 3D movie, you know? What you see looks 3-dimensional, but all the information creating that illusion is stored on the flat, 2-dimensional screen. So the holographic principle suggests our entire universe works just like that. There's this cosmic screen at the edge of space-time, and everything inside, you, me, the galaxy, we're all part of the projection. It's just a mind-bendingly brilliant way of showing how a 2D surface can hold all the information for a 3D world. And the scale we're talking about here is just staggering. I mean, it's hard to even wrap your head around.
Physicists calculated that the size of one single bit of information on this cosmic surface, they call it the Planck area, is an impossibly tiny square. We're talking 10 to the power of negative 35 meters on each side. And every single thing in our universe can be described by these little pixels of information on that distant 2D surface.
So let's take a breath. What does this all actually mean for us, for reality? Because if this principle is correct, it forces us to completely reevaluate what we even think of as real. The implications are, and I'm not exaggerating here, absolutely staggering. First off, it means that the three-dimensional space we live in isn't fundamental. It's not the base layer of reality. It's what physicists call an emergent property, basically a construct that's projected from that 2D surface. So yeah, our world could be, in a very real sense, an illusion. And here's the kicker. It totally solves the black hole paradox. The information that falls into a black hole, it isn't destroyed. It gets smeared out and stored on its two-dimensional event horizon. Just like how the universe's information is stored on the cosmic boundary. The information is saved. And in the end, Hawking himself actually conceded the debate. But of course, this just leaves us with one final, dizzying question to ponder, doesn't it? If our 3D reality is just a holographic projection from a 2D surface, then what lies beyond that surface? What's outside the screen? And with a question like that, physics opens the door to a mystery that is every bit as profound as reality itself.